everyone. Good morning, good afternoon, good evening, mostly good morning, I guess, for those joining us. Thanks for being here for another WorldFAIR webinar from our series presenting project outputs. This is the second last webinar, and today we will be talking about geochemistry and disaster risk reduction. Some housekeeping. So this webinar is being recorded. The recording will be published on our YouTube channel and the WorldFAIR website, and it will also be distributed via email to those who attended and registered. Please remember to post any questions in the chat, as there will be a Q&A section either probably at the very end at this point. So as I said, second last webinar. We have one more coming up on the 30th of May at 12 UTC, and we will discuss population health. We have run over 15 webinars in the last year, and our recordings are available on the WorldFAIR website. First, today we will hear from the Geochemistry WorldFAIR work package, and our presenter representing work package 5 is Alexander Prent from Oscope, and some brief intro to the work package. It's looking into bringing the diverse international geochemistry community together and creating a global network of key geochemical data infrastructures. This work package works through the formalization of the One Geochemistry initiative, generation of FAIR implementation profiles and community engagement, and supports knowledge sharing of best practices and standardization of geochemical data. And today, Alexander will be presenting their 3 published reports: the formalization of One Geochemistry, the methodology and outreach, and guidelines for implementing FAIR implementation profiles for geochemistry. Next, we will hear from Jill Bolland from Tomkin and Taylor, who is representing disaster risk reduction, work package 12. And again, some brief intro about the work package, which aims to describe the plethora of detailed, locally specific data and linguistic variants in the disaster risk reduction field and finds ways to unify them. So the work package feels that it is a significant step towards the creation of a common language and mutual understanding within the field. And you will hear more about that from Jill. And she will be talking to us about her published reports, the work package's published reports about domain-specific FAIR vocabularies and their case study experience. And before I pass the floor on to Alexander, our first speaker, just a reminder that on the 22nd of May, we have the first of the 2 closing sessions of the WorldFAIR project. The first session at 12 UTC on the 22nd will present the case studies, their experience within the project, their work with using FAIR implementation profiles, and the key recommendations that came out of the work in the past couple of years. The second session takes place on the 23rd of May at 12 UTC, and it will focus on the cross-domain interoperability framework, or the CDIF, which is a key output of the project. Information on how to register and more about the sessions, again, available on the WorldFAIR website. That's it from me, and I will now pass the floor on to our first speaker, Alexander, representing work package 5.
Thank you, Alexandra. Let me share my screen here. I hope you can see that okay.
Perfect.
So yes, I'm Alexander Prent. I'm working with and for Oscope in leading the geochemical work package in the WorldFAIR bigger project. So here I'll present some of the guidelines, recommendations from our case study. And the work wasn't possible without the help and collaboration of Rebecca, Leslie, Kirsten, Marta, Kirsten, Dominique, Lucia, and Angus. So they're all part of the One Geochemistry initiative that I've been working closely with in this project. So geochemistry in WorldFAIR, it's one of the 11 work packages. And as the WorldFAIR project sets out to produce recommendations to make data more fair generally across these work packages and to assess its fairness. This is really focusing on interoperability across domains. And as such, the WorldFAIR project tackles fair data and cross-domain interoperability head-on. Now, that's a big task, a difficult task, and it's only possible through aggregating the lessons learned from its 11 case studies that each tackle fair data and interoperability within those specific disciplines. As the geochemical work package lead, I'll share some of the lessons learned throughout the 2 years past. And to summarize them now and discuss them then in the coming 15 minutes, a couple of the lessons we've learned, take-home messages, are really that one should publish their FAIR enabling resources as soon as possible. Vocabulary, if you generate one, it becomes a FAIR enabling resource for the community, and it's best published as soon as possible online, promulgated widely. Then one can grow fairness on multiple levels, as we'll see in the second deliverable. So fairness can exist and grow from a small group to a larger group to maybe even a global group, and that's all good. Even at the small level, a group can be fair. So generating fair implementation profiles for a data set, a database, a repository. As soon as you list those fair enabling resources, it uses and promulgate those that will also help fairness. And as such, FIPs are useful as an indication of how fair a data set, data collection, disciplinary database is. So it's a proxy tool for evaluating how fair something can be or actually is. Then it's helpful to distinguish fair enabling resources from being technical and being community-driven implementation choices. Then the community can benefit, or the broader group of communities can benefit from a published reference FIP that lists fair enabling resources for a discipline-specific group. So why geochemistry? Well, it's very much needed in sustainable development goals. So geochemical data and geochemistry drives the clean water, sanitation, affordable clean energy, decent work, economic growth, industry and innovation, life on land, and climate action. So for these 6 sustainable development goals, it's particularly necessary to have geochemistry as a discipline. And with that, fair geochemical data becomes more and more necessary. That to enable researchers to reuse data in large-scale or big data research problems and across disciplinaries. So this case study focuses on the sharing of best practices and standardization where possible of geochemical data. And one of the outputs of the project has been the One Geochemistry website and the formalization of the One Geochemistry initiative in a formal group. Why grouping is important? Because the geochemical community is actually very diverse and generally produces data that are highly specific and small in size. So here you see a dinosaur with a very long tail, and geochemical data is represented in the tail of this animal with its very specific and very small number of results, exemplified by the 3 data types in these graphs. On the bottom right, there is some trace elements and normalized to a reference material or a widely used normalization strategy, some isotopic data in the top right, and then what's generally first done, the geochemical whole rock analyses there on the left. These are just 3 analytical techniques widely used, and they are quite different from each other, although all related to chemistry. And then you can get to these results via a number of analytical methods methods that each or one of these analytical methods have multiple names, and there's a lack of standards generally. So a bunch of challenges there for the geochemists. And in verifying geochemical data, joined the WorldFAIR case study, and the work package set out to formalize the initiative, determine a minimum set of variables, determine minimum required metadata for samples, and develop a set of implementation profiles that then relate vocabularies that can be published in Research Vocabularies Australia as a permanent and machine actionable vocabulary service. So making sure these FIPs can be used by laboratory, repository, or publishers, then they can be useful for quality control and quality assurance of the data that's submitted there. That all towards geochemical data standardization and fairer geochemistry. Here an overview of the case study deliverables we've worked on in the last 2 years. And one of the outputs was to formalize the One Geochemistry international collaboration in the One Geochemistry Co-Data Working Group. That was the first deliverable. And the geochemical scientific content component, milestone 6, was a deliverable, or not a deliverable, but a milestone that describes ideas and concepts that were then made more solid or solidified in the second deliverable. And some of the outputs there: analytical methodology vocabulary published in RVA from milestone 6, and thoughts about different community complexity and size in deliverable 2, and a fair and a implementation profile that can be used as reference for the community in the third deliverable. So first up was the formalization of the One Geochemistry initiative. This is an international initiative facilitating geochemical science or geoscience through data standardization, collaboration with European Plate Observatory System, EarthChem in the US, Astromat in the US, DIGIS GeoRock 2.0 led from Germany, OzGeochem, and another repository in Australia, the Australian Research Data Commons, GFZ Data Systems, also a geochemical data specific repository, discipline specific, and NFDI for Earth, a German national research infrastructure initiative. So you can see this big collaboration, international collaboration, and that it's important for unifying a diverse group of subdisciplines. And as such, we also see this as maybe a challenge in almost discipline cross-domain interoperability, because there's so many subdisciplines in the geochemical community. Some of the highlights obviously was the Co-Data Working Group formation, One Geochemistry Co-Data Working Group. We had a lot of success with community engagement, where many of the existing societies, associations, and union involved in geochemical data support the One Geochemistry initiative and endorse it. Then the website, where there's a list of best practices available and our mission and vision, and engagement with manufacturers who could be instrumental in producing standardized data. Publications from this initiative: a community effort from a workshop was published, and many of the recommendations there were followed up in this project, the WorldFAIR Geochemistry Work Package project. An vision paper was published, and analytical methods were published in RVA as a vocabulary. Then for Work Package 2, we were asked to provide a FIP, a Fair Implementation Profile, which was actually very helpful in looking at what resources were available in making geochemical data more standardized. And this could also then be used to look at a data set itself or a repository in what technology that data set or repository uses in making its data fair. So a big table here was published that lists for all of the project proponents' repositories, what technology they use, for example, IGSN or OrcIDEA, to associate a person's idea to a data set or even to a data collection in the repositories. With ongoing work in milestone 6, then we said, okay, these vocabularies or FAIR enabling resources can exist at multiple levels, and in a local, and a regional, international, and then a global level. And these resources should be published as soon as possible. Vocabularies, especially following the 10 simple rules for making a vocabulary fair from Simon Cox in 2021. And one of these vocabularies was then published with the help of the One Geochemistry initiative groups. And Stephen Richard managed to publish that in Research Vocabularies Australia, Analytical Methods for Geo and Cosmochemistry. From that milestone 6 and the granularity or the complexity, I then went on to look at how data can be looked at its primary form. So you have a data set that's collected in defined by a theme or category. And if you look at this can be fair in itself, then collecting a few of these data sets in a collection, if you manage to apply the same structure, schemas, and vocabularies to those data sets each, then it becomes a fair data collection. And if you then merge many of these data collections into a disciplinary database, you have to be aware that they need to have the same schema, vocabularies, and technology behind them that makes them available and reusable, that they are, again, fair. And this is complicated, obviously, but looking at in this stepwise manner can be helpful in solving some of the problems that and some of the challenges that are there. The repository then becomes the largest or the most complex means or way of having data available to the community. So as such, you can apply this FAIR implementation profile to a data set, to a data collection, a data repository, or a disciplinary database. Those various data granularity steps becoming complexer as we go to the right. So FIP is actually very handy there to look at what's missing, what technology is missing or needs to be developed, or which FAIR enabling resources are duplicated in addressing one of these lines. If you have F1, there can be multiple identifier types used in a repository, because a repository is a collection of collections, and it's logical that there's multiple FAIR enabling resources used in that repository. If you list them, make them available to the community, at least the community knows how and what technologies are used. So this is pretty handy for us as the geochemical community. And the community can become more complex, and fairness becomes more difficult if we make the community more complex, because a local group of 5 people can easily communicate and use the same structures and know of the data that's available. Then if you grow that community to a regional, international, and a global community, fairness is more difficult to achieve for those more complex group sizes or more complex groups, communities. And then my question here is really, is FAIR only applied to when we have a global community? But I would say that you can be fair regionally or you can be fair internationally. So in that second deliverable, we also found that with looking at the FIP and its fair enabling resources, that it's handy to define which fair enabling resources or the fair guiding principles need technical implementations or community implementations. And the technical implementations here are highlighted in red. And often they are needing some community input as well. But now you can really say, okay, the red fair guiding principles are actually needing to be solved by a technical group or by the community, the geochemical data experts or the geochemical technique experts. So this is quite a good way to distribute tasks, I suppose, when you set up a repository or a database. For our community, we thought that a reference fair implementation profile is also very useful. And this is an attempt to list all the fair enabling resources for a particular principle. Here, one of the principles, when you list all the fair enabling resources in a spreadsheet, perhaps not such a good way yet to produce such an overview, but the best possible at this point. And combining all of the technologies that are used by the project proponents over the globe is a pretty impressive feat result for this project, I think. There's a diverse thinking in the geochemical community, and having this overview there with all of the groups, the project proponents being open about what they use in technology can actually be useful for new groups generating repositories, new groups making their data sets, data collections fair. So if they look at this fair enabling resources overview, they can pick and choose one. What do I want to use to apply a geochemical or geographic information system here, a profile ISO 19115? And how does it look like? What do I need to do to implement it on my data set? So this will help make a larger group of people fair and make it possible to map across these fair enabling resources. It's going to be easier. So that was done in a one geochemistry initiative between these groups, EarthChem, the GeoRock system of Digis, and the OsGeochem system of the Oscope Geochemistry Network. And we published that in the third report. Once more, the take-home messages: publish your fair enabling resources soon, and publish them as is, even if they are for just a local group of people, then still publish them. Mapping is enabled. As soon as you don't know of anything, you cannot work towards mapping anything. So publish them. Grow fairness on multiple levels. It's fantastic if you can be fair on a local level and then on a regional level, big step. So don't hesitate to do it. If it's not international straight away, small steps are also very useful, making geochemical data more fair. Then generating this FIP, great step, publish it too, so people know what technologies are used. FIPs, you can use them as a means to indicate how fair your data set, data collection, disciplinary database, and repositories are, and divide and conquer in technical and community implementation choices of those FIPs. And create and use the reference FIP. It's an open document, so we can add to it. Here are the outputs and deliverables, a list of them. And with that, I thank you for your attention, and any questions are welcome. New jobs are welcome too, because the project is finishing. And let me know when you're interested. Thanks.
Thanks, Alexander. I think we can move on to Jill's presentation and take any questions at the very end.
Yep.
Those attending, please remember to post your questions in the chat. Jill, the
I
floor is
will
yours.
unmute myself and start my video and share my screen. Okay, hopefully you can all see that all right.
Perfect, thank you.
So my name's Jill, as Alexander has said. Sorry, I don't know why. Oh yeah, here we go. And myself and Bapon, who both worked for Tonkin and Taylor, did the disaster risk reduction work package for the WorldFAIR project. And mostly for this webinar, I'm going to concentrate on the sort of conclusions and recommendations we made. Because basically that was sort of the culmination of all the things we found in the project. So that's what I'm going to concentrate on today. But just the idea of fair data for DRR, I mean, I'm sure all of the work packages found that the range of data that was used was very diverse. They had a whole lot of different users. But I would sort of argue that with DRR, that diversity is sort of on steroids. If you think of the people who use and generate DRR data, it's basically everyone, local people who are impacted by disasters. It could be anyone at all. You've got the governments and agencies that are making policies about disasters. You've got scientists that are collecting data and researching disasters. Then you've got things like automatic weather stations, or instruments that are automatically generating DRR data that can be used. Social media is becoming a really rich source for DRR data as well, when people sort of do media reports and images about what's happening in their local area. And it comes in the form of statistics, satellite images, disaster impact resorts, all sorts of stuff. So we have a very, very diverse range of users and data types. And most of it is not fair, unfortunately. So as I said, most of the information here has come from our WorldFAIR recommendations, findings and recommendations report. And that's the third report. The first and second reports were about our case studies and vocabularies. But I've also got a few images and things from this UN DRR report about closing the disaster gaps. So here we go. First of all, do we have the disaster data that we need for DRR? My opinion is no, we don't have that. We have a lot of data, but there's a lot of problems with it. It's unreliable, it's incomplete. There's different databases, they all say different things. They don't talk to each other. This has improved a lot because it's not like I'm not saying something that people don't already know here. This is something that is well recognized by the UN and many people who are working in this area. And it has improved significantly. I use a disaster database called the MDAT disaster database. And I think if you only want to go from 1995 onwards, it's usually quite good. Before that, there's a lot of bias. Rich countries are more likely to be reported. The amount of damage it's missing for lots of small disasters. Only big disasters are in there. And really it's skewed towards rich countries before that. It's not really anyone's fault. It's just who was collecting the data, how they collected it, that sort of stuff. And you think a lot of data we get is from the insurance world as well. And so only people who can afford insurance get to have their data included in those data sets. So there's a big problem. It's very hard for people like me who want to do risk analysis and try and inform people about their disaster risk. If we don't have really good historical disaster sets, it's a really hard thing to do. It skews our knowledge about global patterns and trends. There's a really big thing about, has there been an increase in the number of disasters and things like that? And there has, but there's been a bigger increase in the number of reported disasters. So being able to understand how disasters are changing relies on having a really nice long period of data that we can compare it to, and we don't really have that at all. It can distort our idea of climate change. Another thing, how do we know if things are changing due to climate change if we don't have a really good idea of what happened beforehand? There's also a lack of standards. As Alex Pate mentioned before, there's lots and lots of standards and everyone seems to have their own favourites. And then this other idea is data is often aggregated up to maybe a national level, or even a yearly level, some of the data I found, or even decadal level sometimes. And when you aggregate data to that extent, it's very hard to really understand what that local impact is and to do really high level risk analysis. So that is basically my first, here's some idea. This is the MDAT database that you can see in green, and then this is data from the India National Disaster Authority. And you can see it's there's a lot of differences in that data. Which one's right? I would probably say the NDMA. Perhaps it looks like we're getting better, but again, this might have just been a really big event, and so that it was really well reported, and that's why it looks so good. Here's some more stuff here. This is from the, oh, sorry about that. Sorry. See if I can go back to there. Sorry about my heading and text it. But this is from that UN report I referred to at the beginning. This is the percentages of missing impact data from natural hazards in this MDAT database. I use the MDAT database a lot as an example because it's one of the most widely used disaster databases in the world. So that's why we've got it in there. So look at this, reconstruction costs. 96% of data about reconstruction costs is missing. Insured damages. Insurance companies don't really like insuring data. They give it to you if you're forced them to, or governments force them to, but generally that comes aggregated as well. So, you know, there's not much information on that. Probably the things that are most agreed on, and this might be, you know, a good thing too, is that the actual human impact of disasters, things like that. And again, part of that is because when a lot of people are affected, it becomes a widespread, more well-known disaster. So there's more information about it. So that gives you an idea of where we are right now. And it's, I know, you know, it's a huge effort and there's lots of people, but a lot of work needs to be done. But everyone recognizes this, and there's a much more smarter people than me working out how to do it, how to make it better. But here's some of our recommendations. So I've got recommendations here that I'm going to go through about what we can do about the data, how we can help local governments and governments to how to secure the data better, and my last one is going to be a little bit about how we can improve interoperability. So here, these are the data recommendations. So obviously, given what I've just said, we need to improve our data. Whatever we can do, we need to go back and fill in all the gaps of that data. I mean, it's all right to say just go from 1995, but that really means we've lost a lot of historical information. We might not be able to go all the way back to that, but you know, it's an urgent recommendation from us. The data is inaccurate, incomplete, and unreliable, and we need to fix it. Some of our suggestions were you could use satellite imagery. This has already been done. Google's doing a flood database. NASA's doing it. They're using satellite imagery to try and sort of detect areas that are impacted and things like that. Newspapers, Facebook, X, all sorts of social media reports can probably be used to help us fill in some of these gaps. Wikipedia is actually probably the biggest global memory of disasters. Every big disaster will have a page in Wikipedia. UN Relief Web is similar. There's a lot of pages for that. You know, there's a way that maybe we can use AI to really help us troll through all of these disaster sets and try and fill in our gaps. And yes, please start today is our recommendation. The other thing, and this is very dear to my heart because I'm very much a spatial analyst as well as a risk analyst, is having a spatial footprint connected to the disasters and the disaster databases would really help. It's really, really crucial to understanding you know, how big these events get, the geographical spread of them. You know, unless I'm doing a study at the moment where I'm trying to predict disaster risk for several countries, and we're trying to work out a 1 in 100 year loss. You know, if we had a footprint of a 1 in 100 loss in that disaster database, I could almost take it and overlay it to, you know, different areas, or say this is what the exposure is now. What would happen if the same event occurred there? But it's very hard to get a spatial footprint. We quite often have an XY location or maybe a village, but actually having this spatial footprint of the disaster would be fantastic. We can then start using it to simulate new events as well, if we want to try and get an idea of maybe a 1 in 500 or 1 in 1,000 year event. I mean, things like that. You might, if you're lucky, you might have one record per continent, or two at the very most, but it would help us simulate disaster events for those types of really, really severe impact events. It also will help us understand more patterns. You know, we can see how the disasters maybe correlate with other disasters or correlate regionally, and things like that, you know, monsoon patterns, things like that. How can those disasters help us understand patterns that we know are in that climate? And again, the trends. Can we see an increasing trend of the size of disasters or not? Things like that. And again, those spatial footprints are really important for explaining, you know, for disseminating and communicating risks and impacts. You know, if you get to see a map with your house on it, and you see where those flood maps have happened before that, you just, you know, it gives you a much better understanding of the impact that might have in your local community. And it just really engages the public a lot more, being able to see this stuff on a map. So that was a big recommendation for us. This is an idea of cyclone hazard cones. Now, this is down to the district level, which is quite a low level. And it really can only be done by actually having really good spatial data of exactly where disasters occurred. So that's my roundup of how we can maybe improve some of the data. I haven't put in every single recommendation that we've put in the report. I urge you to go and read it, and also that UN one that I alluded to in the beginning. So those are sort of highlighted ones, and probably ones that are sort of dear to my heart. But the next thing is, how can we support countries? Like, you know, countries are collecting disaster data all the time. There's statistics on them, the national, you know, the disaster management do post-disaster needs assessments. It's getting collected all the time. But it sort of sometimes just gets stuck. It just collected and then it doesn't go anywhere. So how can we start provide support for countries? The good thing about this is that it's already been done. There's a lot of really good, the UN, the World Bank, European Union, all sorts of agencies are really working to help regional and national agencies to collect and disseminate their disaster data. So I guess basically, you know, our recommendation is keep doing that, you know, keep providing support. We've got to provide support for governments to provide their data in a digital manner. And here's some examples: having standardized numbering systems that could be used, really promote the use of evidence-based measures, although you need quality standardized disaster data to do that, but actually sort of showing people how, if we can use evidence to make some of these policy decisions, how much better it will be, how transparent it will be, and things like that. And what have I got? Use disaster collection management practices. Oh yes, because we've got a lot of global progress. The Sendai framework for disaster risk and reduction, they have heaps. They have quite a few, you know, items specifically referring to reducing fatalities from disaster, reducing the amount of people affected by disaster, increasing the resilience of buildings to disaster and things like that. But we can only know if we're meeting any of those goals if we have really good disaster data collected, so that we can then start comparing the goals and seeing if we're moving towards those targets. And again, address the existing data gaps and quality issues, and start having these common data reporting standards and tools. And that's something that global agencies and local and regional agencies can really help with. This is another thing, nothing about us without us. We forget this a lot in DRR, especially sometimes people like me who, sit at desks and look at satellite images for days on end. And I went to the UN DRR conference in Australia last year. And there was a group of women from Vanuatu who have taken this as one of their slogans. And in the aftermath of a huge cyclone, they set up these idea of information centres for women, where women could go along, find out what was happening, understand, where supplies were, things like that. And it was a safe place for these people to go. And their whole thing was, if we have more women leading in disasters, they sort of understand, there's an idea that they understand the needs of the whole community. They're more likely to understand the needs of elderly people, children, people disabled, mostly because they're the main caregivers. That hopefully will change over time, but make sure local people who are really impacted disasters are part of the process, part of the research. We shouldn't really be needing to be saying this in the 21st century, but really any policies that are going to impact people, people should have direct participation in those policy decisions. And again, we really, I think sometimes, probably because we don't have the data for it and it's so hard to get, is we underestimate that local knowledge. Local farmers, local people living in disaster-prone areas, they often have a much better idea of the local impact of a disaster than someone who's studying disaster at a regional or global level. So making sure that local knowledge gets put into disasters, disaster data and risk policies will also help. If we're going to research people, we need to make sure there's a clear benefit for those people that we're researching. Disaster data is very private. It's about impacts of you and your family and your property and your livelihoods. That's quite sensitive, private information. And if people are going to share that with us, we've got to make sure that there's a clear benefit for those people in those countries. And anything that we do collect, we must make sure that it's disseminated in ways that people can understand it and in formats that they can access it with. So that's a plea for making sure, the local and the global, the scientists meet somewhere in the middle and discuss and share their data properly. And now I'm just going to talk about interoperability, and I'll be very quick with these two slides because I can see we're running out of time. So this is just some images from our case studies that we did in our first deliverable. And what we did is we looked at we took two countries, Fiji and, oh God, sorry, I've forgotten the other country. It will come back to me immediately, but we took two countries. And what we did is we took a whole lot of different elements of FAIR, and then we measured what proportion of each data set that the countries use met the FAIR criteria. Findable was quite often used, was probably the one that everyone scored the highest on. Interoperability was the one that everybody scored the lowest on. It wasn't surprising because interoperability is probably the hardest part of FAIR, or one of the hardest elements of FAIR, but that was definitely came across in our case study that interoperability was very low in a lot of data sets. And, there was things that could have easily been changed. Rather than having PDFs, could you have CSVs, things like that, that might actually just increase interoperability. So how can we improve interoperability? Again, this is not all the recommendations, but this is just a couple of them. This idea of creating a DRR metadata standard. Now, I know everybody has new standards and there's all of that, and you don't want another standard just to have a new standard. But I guess the idea is more about understanding all of the metadata standards that can be used for DRR data and finding a way to link all of those. So, you know, one of the things we have is statistics from censuses, you know, and there's definitely a metadata standard for census data. There's a metadata standard. The Dublin Core Metadata Standard covers a lot of data that's collected and things like that. So it's more about how can we work out a way of joining all these metadata standards together so that we know which ones are used, and then maybe we can find a way of increasing the interoperability between them. There's lots of different terminologies, there's different vocabularies, you know, different terms mean different things. And I think if we had some sort of metadata standards in there, we might be able to join a lot of this data up. One of the things a metadata standard is here, I think, where I say that, you know, we need to know what were the conditions when the observation was made or measurement, any aspects that may affect its use or understanding. So, you know, this idea that can we make sure all the observations we have are fit for the intended purpose? And metadata is pretty much one of the ways we can do that. And how can we find a way? I don't really have too many suggestions on this, but maybe we can start thinking about how can we link all of these different metadata standards. And sort of part of that as well is maybe we can have an idea of a data model for disasters. So the reason for this is we have lots of different people. When there's a disaster, you've got people who did preparedness, who collected data about disasters in the first place, maybe got everything, you know, emergency responding and all of that together. And then you've got the response during a disaster, and that has data for itself, and that has different people who are part of that process. And then you also have the recovery process, which is, again, different types of data, different people doing it. You know, these are people rebuilding roads, rebuilding bridges. Emergency responses are rescuing people, finding out where the disaster happened. And then, you know, the preparedness is sort of understanding what happened in the past so that we can be ready for the future. And a lot of times those three phases, they're not necessarily linked very well. So if we could maybe come up with an idea of a data model for a disaster, then we can find a way of linking that, because, you know, a data model or a knowledge graph, you can see the flow of data, you can sort of visualize things like that. And that will really help with situational awareness, collaboration among response teams, and, you know, hopefully lead to more efficient and effective emergency responses. So that is the end of mine. Thank you very much for listening. And yeah, any questions, if we've still got time for them, that would be great.
Many thanks, Jill. That was great. So now, any questions from our attendees for either Jill or Alexander? Right.
Hi, everybody. Yeah, it was a question for Alexander. So it was just on the so you talked about obviously the developing the FIP for geochemistry, but did you find that it was sort of sufficient for to kind of describe the particular processes of research in geochemistry? Like, did it ask the kind of right questions, or did it provide enough to kind of settle, you know, the lines in the FAIR implementation profile? Did they provide enough sort of chance, I guess, for you to provide a good enough level of nuance for geochemistry?
Yes and no. I suppose that's the point of applying the FIP or making a FIP for various levels of granularity in the data. So if you make a FIP for a data set, and then it usually has one entry per principle, so that would provide enough information to understand the data set, or to technically understand the data set, I guess. If you have a FIP with a data set, that allows you to know the schema, the vocabulary. But as soon as you go into a data collections or collection of data sets, there will be multiple entries per principle. So you might have used more vocabularies to describe, because you have multiple data sets that each have their own vocabulary. And then it becomes a bit more complex or obscure as how to map between data collections, because you would have multiple vocabularies, and then you integrate two data collections, so a bunch of data, and then you maybe have 8 vocabularies or a bunch of schemas. So that makes it more complex. Yes. Does that answer your question more or less?
Yeah, I was kind of getting at what I was sort of thought was the case. I think that's similar between not just geochemistry, obviously, but across a number of different disciplines. I guess that mappings between different sets of semantic artifacts is a big issue.
Simon, did you want to add to that? Your camera came on.
Yeah, thanks. I mean, I thought one of the things that's very interesting that came out of the case studies is that very few disciplines are monolithic in terms of their methodologies or their data types. And so that's clearly true, and I think that comes over very strongly what Alexander has said, and it's true of most of the WorldFAIR case studies. So this is maybe obvious, but really important for us to remind ourselves that when we're talking about a domain-specific or disciplinary implementation of FAIR or a set of metadata standards, that is a really complex thing. And that said, for all that diversity in geochemistry, I think Jill is right when she says that the diversity of data types and the complexity of the issues and the methods in disaster risk reduction is on another level. I mean, and everyone thinks that their own discipline has particular challenges, but it really is extremely complicated with disaster risk reduction, and I think that's something that comes over very strongly in what Jill has said. And so what do we do about that? How do we address those challenges? And this is more a comment than a question, but I hope that the other big output that comes from WorldFAIR, the CDIF, will show the cross-domain interoperability framework, will present a set of guidelines of how we can start building that broad data model. Obviously, knowledge graphs will be part of that. One of the big challenges, as Alex already mentioned as well, and Jill alluded to, is the information infrastructure in the sense of those agreed terminologies. Without that, we can never know whether we're comparing apples or oranges, or apples and pears, depending which version of that analogy you use. So there is a lot of work to be done, and I think we need to be quite humble about that. And yet, with something like disaster risk reduction, it's incredibly challenging. So a lot of this is in PDFs, and yes, huge progress has been made with the use of remote sensing data, of course. But sometimes I think there's a degree of, I want to say, I'll say complacency rather than arrogance in the remote sensing community. Oh, we've got all this data, we can use this. Using that effectively on the ground is a huge gap. And I think that's something that Jill's reports point us to, and that we do need to implement FAIR in order to make the most of those data.
Thanks, Simon. We have 1 minute left. Are there any questions, any more questions from our attendees? No? Okay, I do have one last follow-up question about the FAIR implementation profiles, and either Jill or Alexander can tackle it. So would you say that they apply to a specific data set, or are they meant for wider disciplinary communities?
Alex, I'll let you address that.
Thanks for the question. early in the project, early in the WorldFAIR project, we already asked the question, okay, what's the community? And if you write a FIP for a community, how do you divide up the community? But then you can, in my opinion, you can divide it up, a community in smaller parts, or even a data set or a data collection in smaller parts, and then you can show more about that data set or community with a FIP. So it's a good tool to to interrogate or to represent the fairness of a group, and to find where fair enabling resources need to be created for either a data collection or a community, or a smaller community, a bigger community. Yeah, that's useful.
Simon? You're muted, Simon. Sorry.
Sorry. It's a good question, and I think one of the learnings that came out of the project is we did a training with the WorldFAIR Foundation, and they have this idea that you do this at the level of a community. And I think something that we found is that needs to be considerably nuanced. Because as Alex has said, what is a community? And I think that anyone that's interested in the FAIR implementation profiles as a methodology, as a way of gathering information about FAIR implementation and about knowing precisely what resource is being used to make things fair, and that's the real strength of that, would do well by having a look at particularly the Work Package 5 outputs and the discussions of this there. And I have a lot of time for the argument there that we need to focus. It's more useful to focus the FIP at the dataset level or at the data repository level, and that to imagine that, as I said before, that a community is this monolithic thing with only one data type. If you do it at the level of a community, you start listing an endless number of FAIR enabling resources for each FAIR principle, and therefore the utility of what you're doing starts to erode a little bit, I think. It's still a useful exercise to think about it, but then you've got this FIP with, okay, for findability, we use all this. What has that told you in the end? Whereas for a particular database or a data set or a data repository, there I think it becomes very useful information, as this is how we do it for this study, or this that more fine-grained level. And Work Package 5 came up with this vision of a set of interconnected, a sort of pyramidal layer of structure of different FIPs, where a discipline in its complexity and with all its sub-methodologies can demonstrate this is how we do our practice in making our data and our metadata fair. And I think that is a very useful thing to think about. It would require effort, it would require coordination, but I think there'd be a lot of benefit that would come out of that for a particular discipline. So if there's one thing that comes out of this discussion, I would point people towards that thinking in those deliverables.
Thanks, Simon, Alex, and Leslie. You have your hand up.
Yeah, I'd just like to reinforce what Simon said. And when we did it for the repositories, we got a better understanding of what each repository was capable of. But to me, the power was at the data set level, and we translated the geochemistry into some geophysics work I'm doing. And if you've got a FAIR implementation profile for 2 data sets, you can straight away easily mine where the differences are, and then maximize the strengths of where the similarities are. And this is what we found we weren't getting from FAIR maturity matrix or assessments, FAIR assessments. The FAIR assessments were telling us, oh yes, this group's using an ontology and this group's only using a controlled list, but you still didn't know what they were using. And I think Alex did some experiment, I think I'm right, Alex, where you actually had 2 data sets, and it helped you do the merger because you knew exactly where the differences were. And that was, to me, really powerful. And so in another group I work with, we published the FIPS as part of the link to the FIP as part of the data set's metadata. So as soon as you pull down the data set, there's the FIP that goes with that data set. And that's it.
Yeah, I think that's very worthwhile looking at. And then if we think about Jill's case, it would be easy to do a fit for remote sensing data. And then a lot hard. I mean, in principle, it would be easy to do the fit for the in situ survey data that's often a part of disaster risk reduction. But then to try and understand, you could do a fit for how you would want the built environment or the loss data to be presented, but that would be a lot harder to do because the data is often inaccessible, as Jill stressed. So there's a whole set of challenges of how you do the same thing for disaster risk reduction, which needs to be addressed, but it requires a lot of stakeholders to consider how to do that and to put that into practice and to see the benefits of it.
Okay, thank you all. Thanks very much for the great conversation and for our presentations. We are 6 minutes past the hour, so we're going a bit over time. Is there anything else that our attendees or speakers would like to raise at this point? No, in this case, I think we can wrap up. Before we go, however, I will remind you to join us for the 2 special closing sessions of the WorldFAIR project on the 22nd and 23rd of May, co-located to the RDA plenary. And thanks again to Jill and Alexander, and thanks to the other project partners and attendees that joined. And see you all hopefully on the 22nd, 23rd of May.
Thanks.
Thanks, everyone.
Thanks,
See you all soon.
everybody.
Thanks all. Bye bye.